This instructional video is about the recursive rule for sequences for both arithmetic and geometric sequences. It is not a required curriculum for Algebra 2 CP course that's offered in our district, but I promise many of my students in my 8th grade Algebra 2 class that I will offer this as an extension. So here it is. When we talked about sequences and series, we were talking about the explicit rule. It's about once we're given an nth position of a sum, we had to tell them, well, what is the value of that nth position? Or if they give us a sum, we have to find which position of the series that you'll find that sum. And that's what the explicit rule was. A recursive rule for sequences, well, it's another way of defining sequences. But in this case, when we talk about the a sub n is related to whatever is in a term that is ahead of it, the preceding terms that is. So with all that mumbo jumbo, let me just quickly show you how it works. Okay, so it says here, write an explicit rule for this given sequence. The initial term is 2, and in this case, a common ratio is 10. So this is a geometric sequence. This is a geometric sequence. And the explicit rule for that, it is written as a sub n is equal to the first initial term of the series times the common ratio raised to n minus 1. To define the explicit rule, we'll say a sub n is equals to the initial term a sub 1 given as 2, and the common ratio is 10 raised to n minus 1. So that's the general rule that we talked about when we talked about the geometric sequences. But now we have a thing called recursive rule. And the way that's written is when we multiply the common ratio to the previous term. So in that case, it's given as a sub n is equal to the common ratio times, well, whatever the one that was before the previous one is a sub that n minus the 1. And that's the recursive general rule. So given the information, how do we write that? Well, it's simply the common ratio is 10 times a sub n minus the 1. But now the way we write the general recursive rule is as follows. We indicate the initial term, because it's all given in relation to the previous term, is a sub 1 is equal to 2, and we say semicolon, or some people just put a comma, and then we say a sub n is equal to 10 times the common ratio times the one before that. And that becomes the general form for the recursive rule. And that's it. Why'd you try that one? You might have to rewind the video to get the idea of how this is the explicit rule and this is the recursive rule. Let me write that down. Explicit. In the past we called this the geometric sequence, the general rule. And now this is the recursive, which defines the series in terms of the value, the initial value, or the term before that. Okay, now you try that one. Okay, so you said the explicit rule, now that we call this the geometric series or the sequence, is given as a sub n is equal to a sub 1 times the common ratio raised to n minus the 1. That was the old thing we learned. Now we're going to write that as a sub 1 is equal to the initial term, which is 10, times the common ratio of 2 raised to n minus the 1. And that is our explicit rule. Now how do we write the recursive rule? Once again, it is given as the common ratio multiplied, is in relation to the previous term. Well, whatever the a sub n is, it's going to be the term before that. First, we're going to recognize the initial term a sub 1 is equal to 10, semicolon. And then we say, then the recursive rule that follows that is a sub n is equal to the common ratio of 2 times the a sub n minus 1. And there you have it. And this is the explicit geometric sequence and the recursive general rule. Very similar to the geometric series or the sequences. Once again, the explicit rule, where we were given either the nth position and had to find the sum, or the value of that nth position, or we were given the value and we had to determine which nth position that was. We're going to now find the recursive rule that is in relation to the previous terms. So here we go. The explicit rule is for the arithmetic sequence was given as a sub n is equal to the initial term a sub 1 plus n minus the 1 times the common difference d. So in this case, the initial term is a 0 plus the n minus the 1 times the common difference of negative 1. Evaluate, you get 0 minus n plus the 1. Let's rearrange it using the commutative property. We just simply say a sub n is equal to 1 minus n. And that's our general rule for this arithmetic sequence, given the initial and the common difference. And that was the explicit rule. Now the recursive rule, when we have an arithmetic sequence, this time, instead of multiplying like the geometric series, now we're going to add. All we have to do is add the common difference to the previous term. So it's given as a sub n is equal to the one previous, which is a sub n minus the 1 plus the common difference d. And so the only information we need is to write down the common difference right here. So we just simply say that is equal to a sub n minus the 1 minus the 1. Let's put a parenthesis around here to make it look easier. And that's a subscript down here, okay? Now, how do you write the whole entire thing to indicate the recursive rule for the arithmetic sequence? We just simply indicate the first number, a sub 1 is equal to 0. And then we say semicolon or comma. And then the ones following that, we just simply say a sub n is equal to a sub n minus the 1 minus 1. And that becomes a general rule for the recursive. There it is. Now, why don't you try that one? All right, once again, the explicit rule or the arithmetic sequence general rule. Okay, and that was given as a sub n is equal to the initial a sub 1 plus n minus the 1 times the common difference d. And this one's easy, just fill in all the blanks. Basically negative 1, the initial term, plus the n minus 1 times the negative 3 over 2. When you evaluate, you end up getting negative 1 minus 3 over 2n. Negative is positive 3 over 2. Combine the like terms. That's like saying negative 2 over 2, so it becomes actually 1/2 minus 3 over 2n. So that's the general rule for the arithmetic sequence given the initial term negative 1 and the common difference of negative 3 over 2. Now, how do you write the recursive rule? Once again, we're going to add the common difference to the previous term. So a sub n is equal to a sub n minus the 1 plus the common difference. So we're going to say now a sub n, that does not change. And I'm writing it a little neater so I don't need a parentheses. And now common difference is negative 3 over 2. Actually, let's do it and go and put that minus 3 over 2. Okay, that's the general rule, the recursive rule. To write the entire recursive rule that indicates the initial term, it is going to be a sub 1 is negative 1, semicolon. And then we're going to say a sub n, the ones following that is going to equal to a sub n minus the 1 minus 3 over 2. And there's your recursive rule, general rule, for that arithmetic sequence. So now that we know how to write the recursive rule, given an initial term and a common difference or a common ratio of an arithmetic sequence and a geometric sequence, now we are given a sequence itself. Now we have to determine what the initial term is and whether it's a ratio or a difference or whatever, and then come up with the rule itself. Remember what the rule looks like. The rule looks like if it is here. Okay, those two. So they're asking us to write either one of those two or whatever the rule may be. So let's determine first of all, this is easy. A sub 1, the initial term is 3. That was sort of a no-brainer. And now, what is the difference or what's going on in between each of the terms? Well, it looks like to go from 3 to 8, you square the 3. So it's 3 squared minus the 1. That gives us 8. And 8 squared minus the 1 gives us 63. So it goes on and on. So let's put it this way. Why don't we say then the a sub n is equal to, for example, if we want 8, we say the one prior, the previous term, is a sub n minus the 1. And what we're doing with that is squaring it minus the 1. And just repeat the cycle for this entire sequence. And that's it. Here's my indicator for the initial term, a sub 1 is equal to 3, semicolon, and then my general rule for the recursive rule here is a sub n is equal to that previous term squared minus the 1. And that becomes my answer. Why don't you try numbers 2 and 3? Alright, so this was kind of peculiar, but it could have been done. 7.2, how do you get from that to 3.2? Looks like all you do is minus 4. And 3.2 minus 4 gives you 0.08. So it's constantly decreasing. So it looks like the common difference for this guy, well, the initial number, a sub 1, is of course 7.2. That's a dead giveaway. And what's going on? It looks like the difference is negative 4. And so all we're doing is taking the initial term. So we could write that rule already. A sub n is equal to, well, if we take 3.2, if we start from 3.2, one before that was a sub n minus the 1. And what are we doing with that a sub n minus 1, the previous term? Whatever that was, we're subtracting 4. And that's the rule. And here's our initial term indicator. There it is. Yeah, that's the answer. And how about this one? Now, if you said, well, it looks like all you're doing is 6 times square root of 2. I mean, whatever it is, square root of 2. And so you got 6 square root of 2 times another square root of 2. Isn't 6 square root of 2 times another square root of 2? Well, the radicands, they come out as a 2, so it becomes 12, which explains that one. Yeah. So again, the initial term, a sub 1, is 6. That's easy. Semicolon. What's the rule? Well, a sub n is equal to, well, let's look at, again, 6 square root of 2. What's happening with the term before? What we're doing with the term before, a sub n minus 1, is we are simply taking the whole thing and multiplying it by radical 2. And sometimes, since that is a factor, sometimes the book will say a sub n is equal to square root of 2 times a sub the previous term, a sub n minus 1. So that becomes your answer. Alright, recursive rule for arithmetic sequence and geometric sequence. Not too bad, huh?